My ImagineIT project has, taken a big change. It's gone through, I've gone through quite a few activities relating to it. And so, you may remember that I was focusing on beauty in mathematics and, bringing the beauty back to math, because I think we spend a lot of time focusing in just on the math that's required for standardized testing, when in reality math is an attempt to understand the world around us by placing patterns into the world around us. And so I wanted to bring some of that back to my class without, of course, losing any of the productivity in preparing my students for the exams that are required. I teach mostly juniors, and so, ACT is, although we are still unsure if it's going to be a state-authorized test, it is the, big test for students as they prepare for their college applications. So, whether the state cares about it or not, it's something I certainly do. But anyway, my project started off the year by giving students a quick fire assignment where in groups of 4 to 5 they were creating posters answering the question, what is math? During the assignment, all students put things on the posters that related to the language of math. They talked about numbers and equations, variables, operations in math, and many of the posters even referred to the fact that math is everywhere, but students weren't really able to bring any meaning to that. They weren't really able to bring anything in depth to the poster relating to how math is everywhere. And so, that really fired me up a little bit to see why this project is so important, because I think it does students a disservice to not show them what math really is. So, the following week, I gave students an article to read about bamboo math, and it talked about how bamboo grows in cyclic patterns to the point where some bamboo, different species of bamboo flower at different times, but that they all flower on a cyclic pattern that is a product of small prime numbers, or products of the same small prime numbers. For example, some bamboo flowers every 15 years, other bamboo flowers every 60 years, right? And so, the bamboo that flowers every 60 years flowers on the same year that the bamboo that flowers every 15 years does. And the reason for that is because the bamboo wants to survive, essentially, and it's kind of they want to overwhelm the predators, the natural predators to the bamboo. And so I gave students this article to read. I asked them to summarize it, and then I went around the room and kind of did like a little book discussion with each group. So I had them do like a story time in their own group where they read aloud to each member of the group, and then I went through and just did like a little book discussion afterwards to see what they thought about it. After that, I spent a brief period discussing Fibonacci with students, and discussed Fibonacci numbers, what they were, the golden ratio, and then I asked students to go out around the school building and to take 5 photographs of something that represented either a Fibonacci number or Fibonacci spiral in nature. And so thanks to the program, I was acquainted with LensMob, and so I used LensMob to have the students, digitally drop those photos, and so we could share them in class. After that, I found a video that takes the first 200 and some odd digits of pi and creates a song by changing those digits to base 12 and to but the video plays a song based on pi in base 12 relating to the 12 tones in music. And so we looked at the video. I talked a little bit about binary, because I figured binary would be a much simpler method or version of being able to share that with them. But this is kind of where my project took a big turn, because I was focusing on the beauty in math, but it kind of changed into talking about the ugly in math as well, because the ugly does exist in mathematical patterns. So in the interest of trying to relate to some of the stuff that my other coworkers were doing, I did a brief project talking about war profiteering in World War II. So we examined different companies in World War II, or in World War I, I'm sorry, different companies in World War I, and we looked at what their profit margin was in 1910, prior to World War I, and then in 1914 during World War I, and we looked at it as if it were a linear pattern, although I know that it wasn't, but it tied best into our linear equations unit. After that, we were talking about, still talking about linear equations, and so I did a unit on breast cancer awareness, and so we talked about the statistics in breast cancer awareness, the likelihood of being diagnosed with breast cancer at certain ages, and we took some real-life data that was found in an article from I can't remember exactly. It was some news source. I can't remember if it was Newsweek or Time or something like that. But we took an article, and the article actually lends itself to a linear regression. So I was able to discuss linear regression. But here's kind of the big project that happened with the ugly in math, is a discussion about World War II. And so our school is fortunate enough to be located near Redgate Woods. It's about a 30-minute drive from the school, and Redgate Woods is a forest preserve of Cook County. It also is the site where the nuclear material was enriched for the 2 bombs that were dropped in Japan. So it was a former military installation, right? The U.S. government actually rented this land from Cook County Forest Preserve, and they built a city in the woods, basically. There were dormitories and libraries and recreation areas. There were laboratories, and the atom was first split inside a squash court at the University of Chicago, but the reactor that was used for that was moved to Redgate Woods in the forest preserve. And so we did this as a big cross-curricular unit. I've wanted to discuss patterns going along with this unit, and so the history teacher said he was on World War II, and the physics teacher, he wanted to talk about, since we were discussing World War II, he wanted to talk about half-life and things like that. And then the English teacher, he brought in different articles, different perspectives of World War II. He brought in stories, real-world accounts of people who lived through the war. And my part, the math part of this, I did 2 things. In class, before we went out to the woods, our ultimate question for this entire unit was to have students answer the question, would they have dropped the bomb or not? Right? If they were given the decision, would they have dropped the bombs in Japan or not? And so my point in this was to impress upon students the magnitude of that decision. And so I actually found a website called, I think it was Nuke Map 3D. And you can type in a city, and you can select the bomb that you want to drop on that city, and the website will estimate the amount of the number of people that would be killed within a 24-hour period. And so, to give students an idea of the decision that had to be made, what I did was I took one bomb and I dropped it in Chicago, and I took another bomb and I dropped it in New York, and I took the two bombs that I decided to drop were the same size bombs, the little boy and the fat man bombs that were dropped in Japan, and the website then calculated the amount of deaths that would have occurred in a 24-hour period. And so this brought up a discussion about the credibility of numbers, the credibility of reports, because I did some research, but I couldn't really find an accurate representation of the number of people that died in the two bombings, because there were numbers that were as low as as low as 10,000, as high as 140,000. So it was a huge range, and so we talked about why that huge range exists, and it's all about perspective and the what each group or each side of the war wanted to share. And then my other part of this was we actually did take a field trip. We took the kids out to the woods, to the site where to the nuclear reactor. The nuclear reactor is actually buried. They dug a trench and they pushed the reactor into the trench, dug like a 40 or 50 foot trench, and they, at another site in the same wooded preserve, they dug another trench and they buried all of the nuclear material. It's still buried out there. And so I wanted to impress upon students the magnitude of the construction that actually took place while we were out there. So what we did was we took a bunch of measurements of where the trench actually was, where the material was actually buried, and we calculated the volume and the weight or approximate weight, right? We can't find the exact weight of the earth that had to be moved just to bury that material, not even to construct the city that was constructed in the woods, but just for one of the big holes that they dug to bury the nuclear material. So that's why this project kind of took a big turn for the ugly in math as well. We're getting back to the beauty in math, but we're relating it to the ugly in math. I don't know if that makes any sense, but it probably will when I actually discuss with you what's going to go on in quarter two. So got a lot of big stuff coming up, but I'll save that for the trip to Michigan State, and I'll share that then because I'm running out of video time. So I will update you further at a later time.